As a smash, you are everywhere. It's like you are MTN. You are MTN, my guy. Or my girl. Is it my girl or my guy? Azu smash. Azu is everywhere. Like Azu is like everywhere. Everywhere you go, Azu is there. You can't be the last born. When you must be, you've got firstborn vibes. Okay guys, let's functionize. Okay. Let's functionize. We've been functionizing for the longest in this channel. Let's functionize using exam type questions here. I've got some exam type questions. Let's get this ball rolling. All right, given f of x is equal to x plus 4 over x minus 2, what function is this, guys? What do we call this function? Function Kimang. What type of function is this? Remember, for our functions, we've got straight line, we've got parabola, we've got hyperbola, we've got exponential. What function is this one now? F of x is equal to x plus 4 over x minus 2. What kind of function is this now? What kind of function is this? Exponential, straight line, parabola, hyperbola. Yeah, can you just hold your horses a bit there, Chopper? You are choppering here. Hi, this is for grade 11. Skim Carlo, when I'm here. When I'm here, Skim Carlo, we are no longer focusing on grade 10. This is grade 11. Grade 11 and 12 specifically. Right. The minute I change channels and come over this side, I'm no longer speaking grade 10 language. Unless there's a certain aspect in the paper that is covering grade 10, I will say so. But let me be specific. Have you started function scheme, Carlo? At school, grade 10 specifically? Yeah, this here is all grade 11, more specifically, but grade 12 obviously as well. This here is, okay, could be relevant to grade 10, this one. Yeah, but then back here, this is all grade 11. Okay, yeah. Okay, so Chopper wants to do the for which values of k. I will create those kinds of questions for 7.2 near the end. Okay, just hold your horses there. It was 7.2. I'm going to add 7.2.5 and 7.2.6, and I'm going to make those kinds of questions that you want me to answer. All right, just hang on, because I want to also address this. No one in the comment section has told me what type of function this is. All right, Flavorful Sense did tell me. Thank you, Flavorful Sense. I actually missed your response there. All right, so given f of x, this is a hyperbola. Okay, yeah, so our hyperbola can be expressed in one of three ways. One, we can express hyperbola in this way. This one we know, it's like standard. Or we can express hyperbola in this way. Or we can express hyperbola in this way. All right, so these are three different ways that a hyperbola can be expressed. Can be expressed this way. Hello, Bodhan. What grade are you in, by the way? I see you are here. Your hyperbola function can be expressed in one of three ways. This is your first way. This is one of the other ways, third way, second way, and your third way. All right. Or you're in grade 11. So guys, if your hyperbola is expressed in this way, this is your standard form. You know this way of expressing it. And Bodhan, if you don't mind, I guess you wanted to request specific things in the live. That's why you were in the other live. You can basically let me know in the comment section, or you can just guest request if there's specific things you want to be asking about. Okay. A over x plus p plus 2, or you can have this function in this form, or you can have it in this form. Now there's a thing about when the function in this form is in this form. Oftentimes when we are given the function in this form, we are asked to actually show that it can be written in this form. So when that is the case, when we are asked to write this function, which is a hyperbola still, and we need to express it in that form, there is a certain way in which we go about it as grade 11 and grade 12 learners. Remember, this is initially for grade 11, but then of course grade 12 learners don't do hyperbola functions as in like the topic again, but they revise grade 11 work, okay, in grade 12 in preparation for the June exams and also for the trial exams and for their finals. So we need to know the grade 11 aspects of the functions, in as much as there's the log functions and the inverse functions that are done in grade 12, but there's also these functions that we need to know from grade 11, and we need to comprehend the concept very well. So if we are given the function in this form f of x, and then they say show that f of x can be written in the form f of x is equal to 6 over x minus 2 plus 1. The question is, how do we convert this form so that it reflects or it mirrors this form? What do we do, guys? Any ideas? How do we convert this form of the hyperbola? You see now what I'm saying to you, or what I said earlier, that this form of the hyperbola function, we are oftentimes asked to write this form in that form, as you see in this question. This form, we are asked to write in that form. So how do we do it? Okay, and what I want you to notice is that the denominator expression is the same for both of your functions, and we need to show that this f of x can be written in that form. We need to show that this f of x can be written in that form. So in other words, we need to convert Mr. f of x to be that form. And the question is, how do we convert Mr. f of x to be in that form? So let us go and write this f of x as he is x plus 4 over x minus 2. Then it would be nice, so nice, to actually have x minus 2 over another x minus 2. Okay, do you see why it would be nice to have x minus 2 over x minus 2? Guys, what is x minus 2 over x minus 2? Knowing that the denominator is x minus 2, what is the relevance of having another x minus 2 in the numerator? The relevance of having the x minus 2 as well in the numerator is that the division of these two expressions will give me a what? A 1. X minus 2 divided by x minus 2 will give me 1. Now, if you look at the expression at the top, I have x plus 4, but I have an x minus 2. Then my question is, what can I add to the negative 2? Are you seeing, guys? What can I add to the negative 2 to get 4? What can I add to the negative 2 to get 4? What can I add to the negative 2 to get positive 4? KZ, you can see, né? So as a grade 11 learner, I know that what I can add to negative 2 to get 4 is positive 6. So when I rewrite this, guys, okay, I'm going to say x minus 2 plus 6. X minus 2 plus 6 all over x minus 2. Now, I can write this as x minus 2 over x minus 2 plus 6 over x minus 2. So, in other words, in the numerator, how many terms do you have? Because x minus 2 is in brackets, that counts as one term. And then the plus separates. 6 is your second term. So I have 2 terms in the numerator over one denominator. So I can split the numerator into x minus 2 over x minus 2 plus 6 over the same denominator. Do you see that, guys? Do you see that? Now, having then established this, what's x minus 2 divided by x minus 2? It is 1 plus 6 over x minus 2. All right. Then, this f of x, because I know that addition, all right, is commutative, 1 plus 6 over x minus 2, I can rewrite this as 6 over x minus 2 plus 1. Remember, 6 over x minus 2 is positive. It's positive still. Remember, the 1 is also positive, so I can add 1. So then I can therefore say that indeed, as required and as expected, this f of x, I have shown that it can be written in the form of f of x is equal to 6 over x minus 2 plus 1. As you can see, 6 over x minus 2 plus 1. I'm done. I'm done. I have expressed this form, the rational form of my hyperbola, into this hyperbola form, which is the standard hyperbola form that I know, which is expressed as a over x plus p plus q. Done. Finished. Okay. All right. So I don't want people saying that him is difficult, him is not doable. Guys, it is doable. Okay. It is so doable. It is so doable. Coefficient for x was 1, so it is very much doable. Okay. All right. Let's move on to the next question. The next question says, determine the equations of the asymptotes of f. Now, I know you guys can answer me in the comment section. So let's go. What would be the equations of the asymptotes? Let's say you were unable to answer 7.1.1 for 3 marks. Let's just say, for argument's sake, you were unable to show that f of x can be expressed in this form. Could you then be able to answer at least 7.1.2? Definitely, because you have the equation that is in the right form so that you can write the equations of the asymptotes. So in the comment section, there are 2 equations of the asymptotes, because asymptotes, there are 2 of them for your hyperbola. So what are they? I see A has written x is equal to 2 as one of the asymptotes. Do we agree? A further added y is equal to 1 as the other asymptote. Do we agree with A? Is there someone else who has a different idea? Do we agree? Or do we feel differently? What is determine the equations of the asymptotes? Y is not. Okay, Praise is saying y is not, but Praise is not saying y is not what? Saziso Boyo is also saying x is equal to y is equal to 1. Okay, that's the second person now that's saying the same thing. Like who? I just need one more person. Flavorful Sense is also saying x is equal to 2 and y is equal to 1. All right, so I think that is 3 individuals. So we can give those guys, those people, a round of a flippant applause. A round of a flippant applause. So, Praise, y is not. I just wanted to get clarity on that.
I think y is not equals to 1 because 1, it is whereby the graph does not exceed, something like that.
Okay. I think I hear what you are trying to say, but remember, Praise, that when we say the equation of the asymptote, we are identifying exactly that place where the graph does not, or the function does not cut that particular horizontal line for the horizontal asymptote or the vertical line for the vertical asymptote. So we are saying that the equations of those lines are individually, firstly, x is equal to 2. That is our vertical asymptote. Then for our horizontal asymptote, we are saying its y is equal to this q value, which is 1. So these are the equations of the asymptotes. The boundary lines where the function does not touch or overlap or intersect. Yeah. So I think you get the idea as to like where the function should not be, right? But then the thing is, when we want the equations of the asymptotes, these are the equations of the asymptotes. X is equal to 2 and y is equal to 1.
Okay.
Are we together, Praise?
Yes.
Yeah, because I want you, when you go to sleep, I want you to praise him and give him the glory so that you don't, yeah, it's very key. Is that the essence of the name that you have, or is it just a random thing?
No, it's a random thing.
Oh, it's a random thing. Ish, man. And here I was thinking like, you're gonna get your praise on tonight, like 12 o'clock vibes, you know what I mean? But yeah, it's fine. It's fine. All right. Okay. All right. I don't know if there's any other questions related to what we've done so far. If not, then Praise.
No, I understand.
Oh, okay. All right. Awesome. Are you in grade 12, Praise? Grade 11?
11.
11. Oh, okay. And so far you are slaying 11, Moss.
I'm trying.
You must not. You must slay 11, Praise. Grade 11 is the best grade to get marks that you've never gotten before. And I mean the highest marks that you've never gotten before. It's the best grade. Best grade. Term one didn't go so well as you would have wanted.
It was well, but not as like I really, really, really wanted, but it was good, not bad.
It was good. Is it something that's open to share, like as to like how good it was?
It was not that good, but the average was somewhere about 70 something.
Oh, okay. All right. And in grade 10, like roughly where were you averaging in the maths?
I was on level 5.
Oh, okay. Okay, then that's progress, Moss. We can definitely celebrate progress. So Yeah, now, all you need to do now for term 2 is to just sort of like, make make that incremental progress and push it a bit further. Otherwise, I'd say that's a great start.
Yes.
Yeah. Okay. Okay. Cheers, cheerio, praise. Unless you want to stick around.
I know.
Okay. Cheers. All right. No, that's good. I love that. Okay, let's move on to the next question, guys. So the equations of the asymptotes. I hope we all got the point of that question. Let's look at 7.2. Given g of x is equal to 2 into x minus 3, the whole thing squared minus 8, determine the coordinates of the turning point. Hey, let's see. Comment section. You guys have a chance there. You are more welcome to request as well if you guys want to chat to me, like in live, time. I'm happy as well. Like praise there. Praise just took the call. Like a pro. The coordinates of the turning point. We've got A is saying there 3 and negative 8. Ngontwana is saying 3 and negative 8. So that's the second response that is the same from both A and Ngontwana. And guys, I hope that when you guys give your responses, that it is not a repetition of what someone else has said, but rather really there's been thought that has been applied and you are typing an answer that is as per the knowledge that you have, because what we want is to really share what we know, so that if there's a correction, we correct the mistake, which is fine. It's okay to mess up. It's okay to mess up there and there as we go along, but once we know what needs to be done and we've got the knowledge, then we need to make sure that we consistently, are doing what is supposed to be done and not the opposite. Okay. Coordinates of the turning point. Do we all agree? I just need a third person to sort of like share what they think, because I have two. Ngontwana shared and A shared, but I need one more person to either, go against what has been shared or to go with what has been shared, so that I can say, okay, guys, finally, this is coordinates of the turning point. When we have a function in this form, g of x is equal to 2 into x minus 3, the whole thing squared. Turning point. Coordinates of the turning point. Okay. Most this one we just read. Okay, we come here to negative 3. Yes, praise. Thank you so much for giving me the third comment that I needed. So I can confirm, guys, that all three of you have responded correctly in the affirmative. So the inverse of negative 3. Okay, if your equation, your function is in this form, this is your parabola form, quadratic form, but it is your turning point form. We call it the vertex form. Okay, the vertex form. So you can take the expression x minus 3 is equal to 0 and solve for x there. So you can see you get x, which is 3. So your x coordinate is 3. Then you take your q value as it is. That is your y coordinate of the turning point. Okay, so that's why I'm very proud of Praise, Ngontwana, and A. You guys 100% responded correctly to the question at hand. Let's go and look at the next question. Does the graph have a minimum or a maximum value? Hence, determine the value for 2 marks. Does the graph have a minimum or a maximum value? Speak to me now. Now I need people to really respond. Does the graph have a minimum or a maximum value? On what basis do we say minimum, and on what basis do we say maximum? What directs us towards the minimum or direct us towards saying it's the maximum. What are we looking at in our form of the function to then make the judgment of minimum or maximum? Do we know? Very good. Praise. 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 Flavorful sense. Thank you so much, guys. Okay, so praise says A. All right. If we look at the form of the function, y is equal to a into x plus p the whole thing squared plus q. Praise is saying we look at a. So in this case, we are looking at 2. Our a value is 2, which means a is greater than 0, which means even when you sad, you smile. Okay, a is positive. Anyone that is positive, definitely smiling. And of course, at the bottom, we have what we call the minimum, right? Because concave up means we have the lowest value, a minimum value, okay? Yeah, but if a was less than 0, we'd have a sad face, which means we'd have a maximum value. So what is the minimum value? The minimum value corresponds with the y coordinate of the turning point. In other words, our q value here. Okay, so minimum is equal to -8, we would say. The number with its sign, minimum, is equal to -8. So since a is greater than 0, a is equal to 2, a is greater than 0 as a result, we say that it's concave up the function. The lowest or minimum value is going to be -8. Okay. I hope we are good. We are feeling that one there. All right. Hope we are feeling that one there. Move on to the next question. Determine the equation of a newly formed function. Yeah, guys, let's take note of this one. Determine the equation of a newly formed function k of x. Now, guys, the reality is that we have g of x, but they are saying determine the equation of a newly formed function k of x. When what? When g of x, meaning this function, is shifted 4 units to the left and 5 units up after it has been reflected in the y-axis. Let's take this in again. Determine the equation of a newly formed function k of x, so the function will be k of x. When g of x. Who is g of x? Here is g of x. When g of x has what? When he has been shifted 4 units to the left and 5 units up. But all of this is happening when? After it's been reflected in the y-axis. So y is equal to 2 into x minus 3, the whole thing squared, minus 8. We need to write down the function of k of x, the newly formed function, and the order in which things have happened. We need to take note of the order, guys, because what they said in English needs to be interpreted mathematically, but in order. When g of x is shifted 4 units to the left, 5 units up, after it's been reflected in the y-axis. So I want to say this. First, reflection in y axis. That's where we are going to start, because they are saying when g of x is shifted 4 units to the left and 5 units up, but all of that happens after it's been reflected in the y-axis, which means reflection in the y-axis needs to start first. Then we shift 4 forward, 4 units to the left, then 3, 5 units up. The order, guys, is of utmost importance, because if the order is done incorrectly, it's possible to not get the proper k of x function, but to get another form of the function, which is absolutely not what we want. Now, can we talk to what reflection in the y-axis means? Okay, this means we change x. If you reflect in the y-axis, the value that is changing is x, the sign. There's a sign change in x. Take that in, and take that in very well. What am I saying? When there's a reflection in the y-axis, there's a change of sign in the value of x. Okay, let me just for a moment, guys, this is very important. Okay, a reflection in the y-axis. If you are this side and you reflect on the other side, this is the y-axis. So in other words, the same image reflects in this side, which means the whatever x values you had here, which were negative, when it reflects on the other side of the y-axis, those y values, those x values that were here, change to positive x values there, but the y values stay the same. All right, so reflection in the y-axis means a change in sign in the value of x. Not a change in sign in the value of y, but a change in sign in the value of x, or the variable x. Shifting 4 units. What parameter does shifting 4 units to the left affect? This, guys, I need to say, is addition to who? To p. Addition to who? To p. All right, but obviously this addition to p will happen after the reflection in the y-axis. Okay, when we shift 4 units to the left, it's not what you think. It's not subtraction, it's addition to p. And 5 units up. 5 units up is also addition, but it's addition to q. All right, so I repeat again. Reflection in the y-axis means a change in the sign of x. Guys, I told you, I said, if something reflects about the y-axis or reflects in the y-axis, who changes? X will change. Your x values that are negative this side will change to x values that are positive this side. But what happens to y? Y will remain that way. So a change in sign in x, remaining y values. Y values remain. All right, a change in x, remain in y. But if we're reflecting, let's say, in the x-axis, who would change? We would change y and then remain in x. I hope you understand that. So let's do this step by step. All right, I am going to take g of x, and the x will change. Do you see that? x will change. Hey. So I'm going to start with the reflection in the y-axis. When x changes, right, then it means, where's my function? Here's my function. I'm going to write is equal to 2 into negative x minus 3, the whole thing squared, minus 8. This is a reflection in the x-axis. But let's do the manipulation. G of negative x is equal to 2 into. Now this expression inside this bracket, I'm going to take out a negative. That leaves me with, if I factorize, take out a negative, what happens? I'm left with x plus 3, the whole thing squared, minus 8. You take that squared, you apply it to the what? You apply it to the bracket. Remember, when you apply an exponent to a bracket, this big bracket, it means you apply the exponent to the sign, right? Which means if you square a negative sign, an even number applied to a negative sign leads to a positive answer. Then you square the bracket. In other words, you'll be left with x plus 3, the whole thing squared, minus 8. That is g of negative x. I would say that my reflection in the y-axis is complete. I'm done. Let me just repeat this one more time. So remember, we said reflection in the x-axis means a change in the sign of x. Change in x. Okay, so that means the x that you had changes to negative, so that x changes to negative. So inside the bracket, you now have negative x minus 3. I take out a common factor of negative 1. I'm left with x plus 3. Apply the square to the sign and to the bracket. So I get positive. But positive what? X plus 3, the whole thing squared, minus 8. That is my reflection in the y-axis. Mission accomplished with reflection in the y-axis. Mission accomplished. And this here, very crucial, that they're taking out the negative highest common factor, leaving the x plus 3 in brackets, very key. Applying the even exponent to the sign and to the bracket, and then for now leaving things as they are. Now I'm moving on to the second instruction. Shift 4 units to the left. This is what shifting 4 units to the left means. Shifting 4 units to the left means, what does it mean? Shifting 4 units to the left means addition to p. We adding who? 4. Because 4 units to the left means plus to the p value, not subtract, but plus 4 to the p value. So our established p value now is positive 3 after reflecting in the y-axis. Did you see, guys? Yo, how important it is to really fully simplify the reflection in the y-axis before moving on to the shifting of 4 units to the left. So we add 4 to the p, which means I'm going to add 4 here. All right. Additionally, 5 units up. That's my third instruction. 5 units up means I do what? To the q, I add 5. Okay. Then, what am I getting as my answer? It's equal to 2 into 3 plus 4. That's x plus 7. Negative 8 plus 5. That is negative 3. So that, my good people, is how you and I reflect in the y-axis. Then, after doing so, we shift 4 units to the left, plus 4. And then we shift, or we move 5 units up. Thank you so much, Z. We forgot to square it. I love that. I love the fact that you are pointing out that I forgot to square. Because I'm telling you, the more we are getting particular about things written down and we can see them, then I have hope, especially for someone who is helping out their dear daughter, that you will forever be winning, right? You will forever be winning when it comes to these types of questions. Okay, yeah. So we are reflection in the y-axis. Okay, fully showcased by these steps up until this point. Okay, then that negative x, we say plus 4, and then we say plus 5 outside. Okay, g negative x plus 4 plus 5. And then of course we know that all of that was the formation of the new function, which is k of x. So there is k of x fully expressed. It's 2 into x plus 7, the whole thing squared, minus 3. Not a problem. Thank you, Fresh, for the you awesome. I really appreciate it. So please, guys, let's follow the order. All right, Andy. Yeah, look at this. This thing, when g of x is shifted 4 units to the left and 5 units up after it has been reflected in the y-axis. Had I not applied the correct meaning to this whole entire statement, I am telling you, you would get a different answer. And if the algebra is not done correctly, then also an answer that's different is definitely going to be there, and you may not get the full marks. 7.2.4, state the range of k of x. State the range of k of x. So what kind of graph are we talking about? We are talking about Mr. Smiley Face. How does Mr. Smiley Face look like? Mr. Smiley Face has a minimum of what? Of -3. That is the y coordinate of the turning point. It's -3. So then the question is, what is the range? What is the range? I don't understand. Y is not equal to -3. Flavorful cent. I don't understand. What do you mean y is not equal to -3? This is the y coordinate of the turning point. Okay. Yeah. So remember, what is range? Range is the possible y values where your function is defined. Okay. And when you look at your range, you look at it from the bottom to the top. Okay. So from the bottom to the top, what is our range? Where is the function defined? We're going to say y is, right? Let me give you guys a chance. See in the comment section. Let's wait for some people to help me out there. What is our range for this function? Witness Maluleke, y greater than -3. Okay, are we agreeing, guys, with witness? Flavorful scent, y is greater than or equals to -3. Abby Brown, y is greater than -3. So Flavorful scent is the only one that is different with his answer or her answer, saying y is greater than or equal to -3. Mr. Aura, y is greater than or equal to -3. Remember, the function is found at the minimum value. It's found at -3. Function passes through at -3. So it is equal to -3. We acknowledge the equality of it at -3, but it's also found above -3. Okay, or we could write the range in interval notation and say y is an element -3 square brackets to what? To infinity. Okay, very good, A. Ish. I A. A. I think A wants to get an A. All right. Okay, guys, can I just get an indication from my people? Who is in this grade? Ashley, Aingege maths. Ashley, are you doing maths, or are you doing maths literacy? Or are you? What's happening there? You make me so sad when you cry like that, especially in my life. Are those tears of sadness or tears of joy? You're making me very sad. Right? I just want to praise him. I just want to praise him tonight. Above the music, above the maths, oh God, we lift you high. How, Ashley? How? Why are you crying? Why do you cry? Yeah, praise. I just want to praise him tonight. Okay, because all of this is coming because who's getting all the glory? God is getting all the glory, guys. Okay, God is getting all the glory. This is like major focus, right? Please. I just need to praise him tonight. Okay, glory is coming through. Papa yini cha uyaphotana Kevin 2.0 or 2.0. What is this? What's happening with Ashley? Ashley? Hey, unonhle. Hey, nonhle. Ay, nonhle. And your name is so beautiful, by the way, nonhle. But when okay, let's move on, guys. From hyperbola to parabola. Okay. Just a sec. Let's do this. Let's add some questions here. Let us add a question 7.1.3 for this question of sketching this. Oh, actually, let's come here. Let's sketch this parabola. I want you guys to sketch the parabola. Sketch the parabola for me, guys. G of x is equal to 2 into x minus 3, the whole thing squared minus 8. And then I'm going to supplement that sketch with some questions that I think are relevant. Because I'm just wondering if this person is still here, was asking me to answer questions related to for which values of k. So I'm happy to answer those questions, no problem. We can look at some questions related to that. I'm just wondering if the person is still here, or maybe there's no need, because if they're gone, what's the point, guys? You do things for people if they are present. This person's not here. Okay, they'll indicate in the comment section if they are. Let me move on. There's a need. So you want me to do the for which values of k questions? There is a need. Look at this. I need you to think. All right, we can try. All right, okay, guys, then let's do that. Then let's sketch. Okay, I need you guys to sketch for me. Let's first start with the hyperbola. And then after we sketch the parabola, we'll do the k value questions. So I think in the next 15 minutes, let's sketch these two functions. Okay, and we're not going to sketch them in the same set of x. We're going to sketch them in different set of x's. So let's, just so that we can check if our sketching skills are good and if we know what we need to consider when sketching. Okay, there we are. The first one, the hyperbola. F of x is equal to 6 over x minus 2 plus 1. Okay, what do we do when sketching a hyperbola? Where do we start? Of course, we know where we start, right? We start with Mr. A. Okay, a is equal to 6. That way it means a is greater than 0. That way we know the odd quadrants are where we can expect to find our function. If those are the asymptotes, then it's in quadrant 1 and quadrant 3. Okay. Step number 2, horizontal asymptote, vertical asymptote. Horizontal, that is y is equal to 1. Okay, the u value. Vertical asymptote, x is equal to 2. The inverse of -2. So far I hope we are all together. So we start with the a value. We check what is the a value, what does it mean, positive or negative, and which quadrants do we anticipate then to find if a is positive. First and third. If a was negative, it will be second and fourth. We then look for our values of the asymptote, your horizontal and your vertical. Horizontal is y is equal to 1. Vertical asymptote, the inverse of -2, x is equal to +2. 3. Then we say y-intercept. Y-intercept, we let x be equal to 0. So that means f of 0 is equal to 6 over 0 minus 2 plus 1. That is 0 minus 2 is -2. x6 divided by -2 is -3 plus 1. We get -2. F of 0 is -2. So our y-intercept, where the graph cuts the y-axis, is at 0 and -2. Just confirm that 0 minus -2 is going to give us -2. A positive divided by a negative is negative, and 6 divided by 2 is -3 plus 1 gives you -2. That is our coordinates for the y-intercept. Let's go to the x-intercept. We let y be equal to 0 there. 0 is equal to 6 over x minus 2 plus 1. We transpose the 1. Hopefully you guys are working with me as well and you're doing it on your own as well. Cross multiply the x minus 2. Distribute the -1. -1 times x is -x. -1 times -2 is +2 is equal to 6. We isolate the -x. We take the 2 over 6 minus 2, which is 4. Then we divide by -1. X is equal to -4. I am great. We're currently learning about laws of and I don't understand law 2. Oh, my dearie nonchalant Amanda. Who's nonchalant? Nonchalant Amanda. Nonchalant Amanda. Law number 2 of exponent says, when you divide same bases, you keep the base. Okay, guys, can you just go ahead and sketch the function so long? Okay, whilst I help this grade 8 quickly. It's very late and I think the grade 8 just wants some quick help here. You can sketch the function so long. All right, I think we have, at least I've helped you so far to get the x-intercept. So it's -4 and 0. Okay, then 4, you can find some additional points if you find that there's an arm in one of the quadrants that doesn't have a point. Okay. And then you can sketch. Then please, guys, go ahead and sketch this function as well. I just want to explain this law to this grade 8 learner very quickly. Nonchalant Amanda. I wonder why the name. What a name. Nonchalant Amanda. Law number 2 of exponent says, if you are dividing same bases, okay, exponents that have the same base. Remember, you guys learned exponents and you were told that this is a base and this is an exponent. And then you were told that the entire thing, the a to the exponent m, is called a power. All right. So very important to note that first. So now with that said, if you are dividing same bases, all right, for exponents, you keep the base, you subtract the exponents. That happens when you are dividing same bases. Your bases are the same, a and a, you are dividing. So you keep the base as it is. Then you subtract your exponents, m minus n. Your first exponent minus your second exponent. It's like even if you have a fraction like this, your bases are the same. This is still meaning division of same bases. When you are dividing same bases, you keep the base. You say top exponent minus bottom exponent. So you say m minus n. That's what law number 2 says basically of exponents. Okay. So if you look at an example quickly, 2 to the power 3 divided by 2. All right. It could be 2 or 2 to the power 1. Because remember, the number 2, even if it has no exponent, means that it has an exponent 1. So if you are dividing same bases, what do? You keep the base 2. Then your left exponent minus your right exponent. So it's going to be 3 minus 1. Okay, you keep the base because the bases are the same. You subtract the exponent. What's 3 minus 1? It's 2 to the power 2. If you're asked to leave your answer in exponential form, you leave it as 2 to the power 2. But if they ask you to simplify it and write it as a number, then of course 2 squared is equal to 4. Right? So nonchalant Amanda, that is an example. Okay. Let's just look at one more example and then I will leave you because I just think. So once again, you are dividing here because you have a fraction. Look at the bases. Base 3, base 3. The bases are the same. So when you are dividing same bases, what do? You keep the base, subtract the exponent. So top minus bottom, 8 minus 5. What's 8 minus 5? 3 to the power 3. What's 3 to the power 3? 27. Because 3 to the power 3 is 3 times 3, which is 9. 9 times 3, which is 27. So that's basically it. If you're asked to leave your answer in exponential form, you leave it as 3 to the power 3. If they ask you to simplify, basically, till the end, then basically you get the answer 27 and you leave it as that. So nonchalant Amanda, I hope you've been helped. Thank you for joining. I have to go back. To my kids now because I was busy with my kids and they're probably wondering, Hypo, this guy. Nonchalant Amanda, you are very welcome. You understand it much better. You are very welcome, my dear. Very welcome. Very, very welcome. Hunter, could you please explain trinomial fractions, please? Afterwards, please. My goodness. Exponential is explain trinomial fractions. Hunter, I'd have to see a specific example because I don't know if I'm quite getting you when you are saying trinomial fractions. A bit of that doesn't really make sense to me. Okay, so my grade 11th and 12th, your functions, able to sketch. Okay, able to sketch. Okay, so let's just check here quickly. Here, y-axis, x-axis. Right, so what I'm gonna do, asymptote, y is equal to 1. So y is equal to 1. Y is equal to 1. Okay, y is equal to 1 here. Then x is equal to 2. X is equal to 2. Let's say x is equal to 2. X is equal. Okay. You label it. Guys, every time you draw in your asymptote, you label it. There's a mark attached to your asymptote and you labeling it. Okay, so y is equal to 1 is there labeled, x is equal to 2 labeled. Then your y-intercept was 0 and -2. So -1, -2, 0 and -2, we are here. Then -4 and 0 was our x-intercept. So that's the same arm, -4 and 0. So here somewhere, right? So that means we do not have any points for the arm in the first quadrant. So what we do is we quickly grab our calculator and let's say we identify 3 and 4. So where x is equal to 3, we go and substitute quickly where x is equal to 3. This is 6 over 3 minus 2 is 1. 6 over 1 is 6. 6 plus 1 is 7. So additional points would be 3 and 7. Let's check 4. 4 minus 2 is 2. 6 divided by 2 is 3. 3 plus 1 is 4. 4 and 4. That's another additional point that I am going to include as part of my sketch so that I can have some solid points for my sketch here. Then what I do is I do the following. Come here. Okay. There. Okay. So it's the y-axis. The x-axis. So remember 3 and 7. So 3, let's say 7 is here. 4 and 4, let's just say 4 and 4 is here somewhere. And then what we do, since the asymptote is there, just go down here, go down there, and return there. So that is 3 and 7, that is 4 and 4. And then I can label this as f of x. Okay. And there's my sketch, guys. My hyperbola function. I at least have 2 points for the arm in the third quadrant and 2 points for the arm in the first quadrant, as I had expected, because when a is equal to 6, a is greater than 0, it means that my sketch can be found in the first and the third quadrant. The first and the third quadrant of the asymptotes, because your asymptotes redefine the boundaries of your quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3, and that is quadrant 4. And the asymptote boundaries define the quadrants where they are located. So I hope that is very clear for all of us how we would sketch our hyperbola. Right, let's go sketch our parabola. So number 1, when we are given the sketch in this form, we first look at a as well, which is 2, which means a is greater than 0. So we are beginning with the end in mind. In rough, we know it's concave up. 2, turning point. Since we can read the turning point from the sketch, very straightforward to read the turning point. We have 3 and -8. 3. X-intercept, y-intercept. X-intercept, let y be equal to 0. Y-intercept, let x be equal to 0. With the parabola, it's nice because it will be straightforward, getting the calculations, no additional points. We just use the given points to basically sketch the function. All right, unlike your hyperbola where a particular arm, you know it's situated in a particular quadrant, but then you don't have specific points because when you found your x and your y-intercept, those x and y intercept only cater for the single arm in the third quadrant. So yeah, that's why it becomes important then to find values that are at least next to x on the other side, so that you can at least be able to sketch appropriate points in the first quadrant, which can then help you with the shape of the function and the position of the function in the quadrants. X-intercept, let y be equal to 0. So let's do it. 2 into x minus 3, the whole thing squared, minus 8 is equal to 0. Take the negative 8 over 8. Isolate the 2. Divide by the coefficient of the bracket, which is 2. Gives me x minus 3, the whole thing squared is equal to 4. Take the square root on both sides. That will help me get plus minus for the square root of 4. I get x minus 3 is equal to 4, to 2, which is positive, or x minus 3 is equal to 2, that is negative. Because remember that plus minus indicates that there are two answers. The square root of 4 is 2. So it can either be positive 2 or negative 2. When I calculate the value of x, it's 2 plus 3, x is equal to 5, or negative 2 plus 3, which means x is equal to positive 1. So my x-intercept is 5 and 0, the one, and the other one is 1 and 0, the other. Repeat again. Look at this. A, it's 2, it's positive, concave up. Look at the brackets. The inverse of negative 3 is 8. Q value as it is negative 8. That is your turning point. X-intercept, you let y be equal to 0. You solve for x. Some of you would have expanded, factorized, and so forth. That's also fine, guys. Don't worry. Okay, that's also fine. Okay, that's also 100% fine. You get your x-intercepts. Then your y-intercept, f of 0 is equal to 2 into 0 minus 3, the whole thing squared, minus 8. Okay, then 0 minus 3 is negative 3. Negative 3 squared is 9. 9 times 2 is 18, and 18 minus 8 is 10. So the coordinates are 0 and 10. The y-intercept. Okay, and I think we are ready to sketch with that information. Y-intercept 0 and 10, x-intercepts 5 and 0, 1 and 0. Okay, and then 3 and minus 8 is the turning point. Okay, so let's sketch this function so that we have an idea as to how it looks. 3 and minus 8, 3 minus 8. Okay, x-intercept 1, 5, y-intercept 10, turn. Okay. Then this is the axis of symmetry. So x is equal to 3. Okay. Then I write the equation of the axis of symmetry. X is equal to 3. Okay, yes, definitely. So x is equal to 3 here. Very good. Remember, that's 5. That is 1. Okay. Then that's 3 and negative 8, my turning point. Okay. And then what I wanted to do is to then cook some questions that are related to for which values of k. Right, because I see that some of you are like those questions for which values of k. Okay, are we gung-ho for those questions? Okay, let's get some. Yeah, so let's just say they had asked for which values of k will, right, will two into x minus 3, the whole thing squared, minus 8 Okay. Yeah, Masi, let's put it like this. For which values of k will a 2 into x minus 3, the whole thing squared, minus 8 minus k equal to 0, have equal roots? Okay. Yeah. Yeah. Okay. So what's important then, guys? For hyperbola, if we didn't get the first question right, I don't understand. What do you mean, which first question? No. Remember, even if you weren't able to show this to be that, all right, even if you weren't able to show this to be that, you'd still be able to sketch the hyperbola, because remember, the reality is that this is that. So that means you can use this f of x and then go ahead and sketch the function. Okay, so even if you were not able to convert it, you'd still be able to. Okay guys, let's come here then. For which values of k will, okay, a 2 into x minus 3, the whole thing squared, minus 8 minus k be equal to 0, right, have equal roots? That's what they are asking. All right, so here's the thing, guys, and I need you guys to listen to me very well. This here, all right, I am going to put in orange. This part here, this this here, right? This is a representation of the function g of x. Okay, this here is a representation of the function g of x, right? So it's like they are saying for which values of k will g of x, because this is the entire full representation of the function of g of x, which is, look at it here, g of x is equal to 2 into x minus 3, the whole thing squared, minus 8. Okay, so they're asking for which values of k will g of x, the entire function, minus k equal to 0, have what? Have equal roots. Now, if we go back to nature of roots, graphically speaking, if ever a function had its turning point touching the what? The y-axis. Sorry, the x-axis. What did we say about the roots of the function? Speaking about the roots of the function, we would say that these represents equal roots. In other words, delta is equal to 0. Whether it's concave up or concave down, if the function touches all but one point, in other words, its turning point touches the horizontal x-axis, then we would speak of what? Of equal roots. Okay? Graphically, if the function did not touch the horizontal x-axis, then we knew that this spoke of delta less than 0. In other words, non-real roots. This is what basically it means when they say we have no real solutions. In other words, there are no x-intercepts, because the function does not touch the x-axis at all. Then delta greater than 0. Now, depending on the situation of delta, okay, yeah, this one graphically represents non-real roots, no real solutions, no x-intercepts. This one represents real roots, or in other words, roots that are there. The roots are real and they are unequal, and depending on the roots, the state that they are in. Okay, it could be real roots that are unequal but they have irrational roots. Okay, or it could be real roots that are rational but have unequal roots. Okay, but in essence, delta greater than 0 represents this. So, guys, I need you now to really be with me and listen to me well here. So remember, I said 2 into x minus 3, the whole thing squared, minus 8, minus k is equal to 0. This part here represents this entire function, g of x, the parabola. All right. Now, what I'm going to do is I'm going to isolate g of x. That's the first thing I'm going to do. So I'm going to say 2 into x minus 3, the whole thing squared, minus 8. Take the negative k over, equal to what? To k. Okay. So remember, I said this whole entire function is representing g of x. So where the function is concerned, where g of x is concerned, the function itself, we are specifically talking about, for equal roots, we are talking about a horizontal line that basically touches the turning point. We are talking about a horizontal line that what? That touches the turning point. It's horizontal. It touches the turning point, which means the y value of this turning point is obviously going to be equal to -8. The horizontal line that touches this turning point is the line y is equal to -8. Okay. We are going to compare that with g of x, which is equal to k. In other words, we are going to compare it with the line y is equal to k. So if we have a line that is horizontal, which is y is equal to k, we want that line to be exactly on this straight line, y is equal to -8. So there are two things here. When we isolate g of x and the k, negative k is transposed, we have g of x is equal to k, but we know most that g of x is just another sweet way of saying y, and y is therefore equal to k. So this is just a line, y is equal to k, where k is an unknown. But for equal roots, y is equal to k, and this horizontal line that we know touches the turning point will adopt the equation y is equal to -8. So these are the two that we are going to compare. For equal roots, guys, for equal roots, since you can see that y and y are the subject, we are going to say k for equal roots is equal to -8. The horizontal line y is equal to k should be exactly on y is equal to -8. The horizontal line y is equal to k should be exactly on y is equal to -8 for what? For equal roots. So we say k is equal to -8. So if you are going to ask me for which values of k will g of x have equal roots, I'm going to answer you that the values of k for which this here 2 into x minus 3 the whole thing squared minus 8 minus k is equal to 0 has equal roots, it will be, firstly, take the negative k, transpose it. This isolates the function, so I know that this is g of x. G of x is equal to the isolated k value. G of x is equal to k, in other words, y is equal to k. So this is a line which has the unknown k. For roots to be equal, this unknown line needs to be exactly on the line y is equal to -8 for roots to be equal. So that is why then I take y is equal to k, which is the random line that I have formed using my transposing of -k to the other side to become k, and the equating of the function which is represented by g of x, which is y, y is equal to k. This here, for roots to be equal, this line needs to lie exactly on the line y is equal to -8, because that is where we have our turning point on. That is where we say roots are equal. So y is equal to k and y is equal to -8. For equal roots, we are going to say, since the subjects y and y are there, we are going to say k, okay, is equal to -8. Okay. Yes, it is the same, but it's just by using our graphs instead of the discriminant, right? But the concept, all right, is still relatively the same. So I know some people that basically do the delta, the discriminant. They will do the calculation for delta on the side and simply come back here and write their answer without using the graphical approach. So if you want to do it that way, you are more than welcome. Just as long as you know, for equal roots, obviously, you would basically write the equation in standard form, then you identify your A, B, and C, substitute, and then of course you would be able to actually set up an equation depending on depending on the situation that is there for equal roots. So this one is the graphical approach. If you are going to use that's what you do, I need you to think, that's fine. I mean, that's fine, as long as you get the answer. If you are going to use the delta approach, okay, let me just show you guys. If you want to use the delta approach, then it's a matter of first writing this in standard form. So if you write this in standard form, that means we would have to literally expand everything. Okay. Yeah, because that's basically, I guess, the thing about writing in standard form. You'd have to expand everything. So we're going to say x squared minus 6x plus 9. Distribute the 2 minus 8 minus k is equal to 0. So you'll say 2x squared minus 12x plus 18 minus 8 minus k is equal to 0. Standard form, 2x squared minus 12x. 18 minus 8 is 10 minus k is equal to 0. So now you have a, which is 2, you have b, which is negative 12, you have c, which is 10 minus k, right? Then what do? We say delta is equal to 0. That's for equal roots. Okay, because remember it says, for which value of k will this have equal roots? So we are going to say delta is equal to 0 for equal roots. Then we know must b squared minus 4ac is equal to 0. We set up an equation. b, negative 12. 4aa is 2c is 10 minus k, which is equal to 0. So you get 144 minus 80 minus 8k. Then 144 minus 80. 144 minus 80, you get 64, right? 64. You isolate. Is it? Wait. 144 minus, what's this? What happened here? For A, C. It's correct. Okay, I'm just thinking what happened there, but because it is correct. It's correct. It's just that I'm asking myself, why doesn't it resonate with the answer that I have there? You have minus 64 that you transpose, you got negative 8k. Oh, that's plus 8k, because the negative 4 times 2 is negative 8. Negative 8 times negative k is plus 8k. I was wondering what's happening there. Divide by 8 both sides. Get k is equal to negative 8. Okay. Yeah, so you see, this is very, for which values of k? Okay, so that's that compared to that. Do you see? Yeah, the same k is equal to negative 8. The same k is equal to negative 8 that you got there. Yeah, okay. Yeah, so I mean that's this is an algebraic approach. Yeah, this one is the graphical approach. Yeah, but it's a matter of being able to check the situation here. I'm gonna show you another one, just since we are still here. They could and they do sometimes do the following. I want you to see this. For which values of k will 2 into x minus 3 the whole thing squared minus 8 is equal to 0 have non-real roots. Now this to me is fun, guys. You have no picture how fun this is for me. Okay, so if you look at this, all right, you're like, this is 2 into x minus 3 the whole thing squared minus k is equal to 0 and have non-real roots. Now, firstly, remember when we looked at the expression and we saw about, oh, this is the full package of the function. Okay, but look at this, 2 into x minus 3. Okay, this I can to your school. Can what? Arnold, what is Arnold saying in the comment section? Okay, Arnold, you're distracting me. 2 into x minus 3 the whole thing squared minus k. Now this here, remember, represents g of x, but here we don't have the full g of x. This is 2 into x minus 3 the whole thing squared. So this does not represent this function, which means we have a problem because this does not represent this function. Remember, guys, that the function is 2 into x minus 3 the whole thing squared minus 8. There's a minus 8 that is missing there. All right. So what we do graphically, all right, and please, guys, take note of what we do. We are going to rewrite this thing down, what we have so far. Take the negative 8, go and negative k, transpose it so that it is k on the other side. But we can see that this is lacking a term so that it can be truly called g of x. What is it lacking? The minus 8. So what are we going to do to ensure that this actually represents the function that we had there? We are going to subtract 8. So I'm going to try and get a different color here so that you guys can get the point. We are going to subtract we are going to subtract negative 8. Okay, I'm guessing it's not going to work. It doesn't want to. We're going to subtract negative 8. But remember, with an equation, what you do on the left, you must do where? On the right. Now I have a full g of x. You see, now I have the function, right? This means g of x, because this is the function. But it is now equal to k minus 8, not just k. So now I know that y is equal to k minus 8. This is the line that has an unknown, which I am going to compare with my horizontal line, y is equal to negative 8. Does that make sense? And this line, for it to qualify for non-real roots, this line coupled with the horizontal line, this line needs to be, in order for it to qualify for non-real roots. Remember, the function needs to be above this line. This parabola function, for it to have non-real roots, needs to be above that line. So y is equal to negative 8 must be greater than k minus 8. So in other words, negative 8 must be greater than k minus 8. Or in other words, we can say k minus 8 needs to be less than minus 8. So for non-real roots, we are going to say k minus 8 is less than negative 8. K minus 8 needs to be less than negative 8. Are we together here, guys? Because this line, for it to qualify for non-real roots, needs to be below the y is equal to negative 8 line. Because remember, the y is equal to negative 8 line represents exactly where the minimum is. But if this line, this one, is below that line, then we know that that qualifies for non-real roots. Roots are non-real here. So here's the thing, guys. This here, this guy there is what we are always comparing the y value of the turning point, the horizontal line that passes through the minimum, against. If it's the maximum, the y value of the maximum, we are always comparing against this unknown expressed function of the straight line. Okay, so please, guys, I hope you guys are understanding this very well. We are always comparing this with that. So if it says equal roots, if it had said equal roots, we are going to say k minus 8 is equal to negative 8 for equal roots. But since it says non-real roots, it means this guy must be below that one. Because the minute that line is below that line, it means we have non-real roots. Okay, and so we can get the values of k for which the roots will be non-real for that function. So that's why we say k minus 8 is less than negative 8. Then we can solve for k. K is less than, take the negative 8 over, negative 8 plus 8, we get k is less than 0. Okay, are we together here, guys? Maybe some of you are asking yourselves, what would we have said if they had said for real roots? Okay, for real and unequal. Then, guys, of course, for real and unequal, it means that the line, the specific line, would be greater than the line negative 8. So we'd say k minus 8 is greater than negative 8. if we were still referring to the very same, expression of the function without the -8, we would put -8 and -8 on both sides after transposing the -k, and then we would compare that with that horizontal line to get the values. And remember, when they say k less than 0, it means there are a numerous amount of values of k. Every value that is less than 0 for k is basically going to be always giving us non-real roots for this specific function. Okay. So this is important. All right. So this is how you do those questions. This is how you do these questions, guys. There's nothing too much to them. Okay. Okay. Are we safe? Are we safe? Are we good? Yeah. Kaitlas, you requested my guy. What's up?
Siyaphila njani?
Eh?
Siyaphila njani?
I'm well, sir. I'm well. Yeah. I see you enjoy selfies. You are a selfies man.
Sithombe nje futhi.
Yeah. Okay. No, it's fine. Anything, my later, I saw a request.
Shama functions.
Yeah, no, we're doing functions, my guy. Yeah, it's functions.
Bengibona into engiyithandayo ama-functions.
Oh, okay. So, former student who loved.
Ngathi vele bengiyithanda lake. Kwamanje kodwa
Okay.
sengiqedile esikoleni ngifundela umsebenzi.
Ngiyakubona ndiyatsho uba hayi uyinkokheli eyagqiba kudala ndiyakuva nje.
Ya mfuthu. Kodwa phela into oyithanda mfuthu. Uzwa?
Ndithi so ke
ngoku. Uthini bafo?
Ndithi uthi yayi into owayuyithanda.
Uthi manje lakhi ngiyayenza imath kodwa lakha awekho ama-functions le math engiyenzayo.
Kukho ntoni bafo?
Khona ama-binary math.
Yeah. Yima ufunda ntoni bafo?
Computer science.
Yeah. Hayi, that's the one. Yeah, ne? Yima so ke ngoku so bethu unyaka esingaphi okanye sogqibile?
Hayi, second year.
Okay. Kuyacengeka noko bafo.
Ngizwa?
Ndithi kuyacengeka noko uyazama.
Kuyancengeka.
Makuncengeke tata, makuncengeke. Khona isikolo eso xa ukulo level it's not easy kodwa ke amadoda ayagqiba sibona abantu becelebrate year in year out, so we are hoping there will come a time and a year when we'll be celebrating your graduation.
Sifisa ukuthi ngaba kanjalo impela futhi.
Hayi tata, kuzawuba njalo. Akwazi uba yenye indlela. I'm sure now maninzi ama-sacrifices osowenzile so far up until this point. Yabo. So
maningi impela.
We baba. So lama sacrifices owawenzile they cannot be in vain bafo. Nokwana like sengisho uba maningi ama sacrifices owenzile so far. It's only nje uba mawuthi xa ulapho kuzawuba nzima, akuzuba lula, phofu manisithi akho lula, kodwa ke hayi indoda kufuneka iphumele and ifuneka iqede and yoyise, overcome uzoba yiconqueror ubalise sakwistory.
Hayi kunjalo mfowethu, khona kunzima ukufunda kodwa iy'thelo zakhona
Yeah.
ezangunaphakade zimnandi.
Yeah, bafo. Yeah. Because hey, ngoku sesibethwa ngama-high sifundini, abantu bafuna ama-shortcut. Yabo, and ke ngoku kuphiliswa abantu kabuhlungu yonke loo nto leyo. So ubhetere uba abantu bake bawuhambe lo mzila unzima, and then umntu akenze into erayithi ngobomi bakhe, into zakwakha, into
Siyakholelwa
engaphutha
mfundini
abantu.
ukuthi zizoshintsha iy'mpilo zethu ngempela imfundo.
Yeah. Hayi bafo, incenge bafo, incenge.
Manje uqedile ukushala ama-functions bafo?
No, bengekagqibi tata, bengekagqibi.
Bafo. Bafo.
Hey, I think inetwork bafo yangilanduka. No, guys, yeah, let's come back here. Yeah, my guy, sterk. Pusha lapho. Computer science, it's not for the faint-hearted, that course, but I've witnessed people finishing that course and coming out tops and graduating and doing some phenomenal stuff in the working world. So I can only hope for the best. Guys, let's come back. I hope this is clear for you, like the whole for which values of k, because it's those questions that sometimes lead people down a rabbit hole. Okay, let's I think we've done hyperbola, we did the parabola. Now it's time to explore a bit of exponential, and then we'll look at other interpretation questions, and that should be it for the night, guys. The lesson is definitely recorded. I'll definitely upload it. Okay. Yeah, let's come up here. Let's come here to this guy. Because remember, the questions I did were just added on. See? Yeah. Consider the exponential function h of x is equal to 3 into half to the power x minus 6. 8.1.1, determine the x and y intercepts of h. For 5 marks, I can okay. This is just giveaway marks. 8.1.2, give the equation of the asymptote of h, another giveaway. Is the function increasing or decreasing? Boom, another giveaway. The graph AB to the power x passes through the points 1 and 12 and 2 and 48. Find the values of A and B. You're setting up two simultaneous equations, solving them simultaneously, getting A and B. Another giveaway. On the diagram sheet, sketch the graphs of H and P on the same set of axes. Clearly label all intercepts and asymptotes. Boom! Another sweet giveaway. Beautiful marks here. 15 beautiful marks just from this. Hi guys. Dijo monati fela. Alright. So with this, alright, remember yes, this is Dijo, bro. So if you think about it, let's just quickly recap. There's some crucial things that we need to note. That when our function a, this is a, this is b, if a is greater than 0 and b is greater than 1, we have a function that is you'll enjoy Tisha once I explain it. All right, I'm unpacking it here for you. Then a, so ab to the power x plus p plus q. This is your standard form of a exponential function. Okay, grade 11s, 12s. When A, meaning this guy here, the A value here is greater than 0, meaning it's a positive value. And at the same time, B, meaning this guy here, the value that is basically the base for the exponents x plus p, when that is greater than 1, then what we experience is a function that is, because A is greater than 0, it will always be above the horizontal asymptote. Exponential functions, guys, have one asymptote. They have what we call a horizontal asymptote. Okay, when A is greater than 0, we say that the function is above the asymptote, and it is, when B is greater than 1, whilst A is greater than 0, it is an increasing function above the asymptote. Q, this Q value gives us the value of the horizontal asymptote. So y is equal to whatever the Q value is. So in this case, y is equal to -6. Right. So when A is greater than 0, B is greater than 1, function above the asymptote. A greater than 0, B is between 0 and 1, like we have here. Then what you expect is that the function will still be above the asymptote, but instead of the function increasing, the function is decreasing. A greater than 0, B is between 0 and 1. This is a typical example of A greater than 0 and B between 0 and 1. Function is still above the asymptote, but it is decreasing. Please take note, guys, of the two scenarios that have A greater than 0. Any A greater than 0 means the function is above the asymptote. Function is above the asymptote. Function is above asymptote. That's what A greater than 0 means. When coupled with B greater than 1 with A greater than 0, we are increasing. Coupled with A greater than 0, B is between 0 and 1, we are decreasing. Then lastly, A less than 0, whilst B is greater than 1. This time round, when A less than 0, we are below the asymptote. I repeat, when A is less than 0, the function is found below the asymptote. When the function has A being less than 0, the function is found below the asymptote. But as it is below the asymptote, when B is greater than 1, the function is actually decreasing. Okay? Yeah. Then when A is less than 0, but B is between 0 and 1. Okay, A less than 0, B is between 0 and 1. Then the function is found below the asymptote, but it is increasing. So these are important concepts for your function. A, this parameter. B, the parameter that is usually inside the bracket, that is the base for the variable. And then 2, the horizontal asymptote. Okay. Now I need to just check with all of you who are here. Are you with me? Okay, indicate please. If A, as I said, he's greater than 0, that means above the asymptote. A greater than 0, that means above the asymptote. B, if B is greater than 1, A is greater than 0, we are increasing above the asymptote. If A is greater than 0, whilst B is between 0 and 1, we are decreasing above the asymptote. The minute we change the position of the asymptotes, we go below, A is less than 0, then the opposite happens. When A is less than 0, but B is greater than 1, then we are below the asymptote, but we are not increasing, but decreasing. When A is less than 0 and B is between 0 and 1, we are below the asymptote, but increasing. Now someone has asked, what about P? Felicia is asking about P. P, all right, when it comes to the sketch, just simply assists me and you about the horizontal movement of the graph. Okay, even though at the same time Q assists with the vertical movement of the graph up and down, but P assists us with the horizontal movement left and right. Oh, you fell asleep. Oh, how cute. How cute. Was there any drool that was coming on the side of your cheek because you were sleeping? I need you to think. Like any drool coming down like as you were sleeping. Did you fall asleep on top of the table? Are you falling asleep because you are sleeping on the bed whilst listening to this? I'm just trying to think of, I need you to think, and what state you were in as you slept whilst you were listening. Or are you trying to say that I have a lullaby voice? Are you trying to say I have a lullaby voice? Unless you like trying to pin me with a lullaby voice, then oh man, it's too cute. So why are you telling the people? You typed it in the comment section. You typed it in the comment section. The people, I'm telling them because you typed it. Are you killing me here? Yes, actually, I do. Oh, hey. You guys are complimenting me too much tonight, that's for sure. Alright, and it's working. It's working. Before you know it, I'll be making all of you sleep. I'll pull my magic trick and just like get you all to sleep all at once. Okay. So guys, one more time. Okay. A greater than 0, we are talking above the asymptote. Above the asymptote when A is greater than 0. A greater than 0, above the asymptote. A greater than 0, above the asymptote. Whilst B is greater than 1 with A greater than 0, we are above increasing. Whilst A is greater than 0, B is between 0 and 1, we are above decreasing. When A is less than 0, whilst B is greater than 1, we are below decreasing. Then when A is less than 0, B is between 0 and 1, we are below increasing. Okay. So now let's get to the questions that were asked. 8.1.1 said determine the x and the y intercept. So x-intercept, we know we let to y be 0, let y be 0, 0. Let's do this. I need you to think. Let y be equal to 0. 0 is equal to 3 into half to the power x minus 6. Okay, let y be equal to 0. Take the negative 6 over. Okay, divide by 3 both sides. Cancel, cancel. 6 divided by 3 is 2. Exponential equations, bases can be the same. Half can be written as 2 to the power negative 1 into x. We get 2 to the power negative x into y is equal to 2 to the power 1. Negative x is equal to 1, therefore x is equal to negative 1. So determine the x and y intercept. Okay, so this is the x intercept. Y intercept, let x be equal to 0. Y is equal to 3 into half to the power 0 minus 6. 3 into 1 minus 6. 3 minus 6, negative 3. Okay, so they just wanted the intercept. They didn't say the coordinates. Okay, so x is equal to negative 1 would be 100% fine, and y is equal to negative 3. Are we in agreement? Good. X-intercept, y-intercept. Oh my goodness, we have DJ Euclidean. Who in the world? Man, people, how do you guys come up with these creative names? It's like DJ Euclidean. Someone's called DJ Euclid. DJ Euclid, DJing with Euclidean. Who in the world, man? Okay, anyways, DJ Euclidean, I think just left the building. Okay, x-intercept, y-intercept, got it, ne? Move on to the next question, 8.1.2. Give the equation of the asymptote of h. Come on, let's get it in the comment section. What's the asymptote of h, guys? Give the equation. Give it to me. Asymptote of h. Marazo. I see you, Marazo. And I'm sure Marazo like feels like I've got it. I need you to think as well. It's like, I've got it. I thought it. Kwanyi is like, you guys don't know how to write an equation, so I'll show you how to do it. Praise is like, I'm gonna write it out in English and then leave out the sign. Felicia is like, let's just do it like Kwanyi and just write the actual equation in mathematical form. So guys, the answer is y is equal to -6. Remember, equation of the asymptote, the q value. You forgot. Praise. I just want to praise you. You see, praise. Shackles of my feet so I can dance. I just want to praise you. Yes, that's what you want to do. Guys, please don't write the numerical value alone. When they say give the equation, remember an equation consists of a left-hand side and a right-hand side. So give the equation of the asymptote of h. Don't be careless here and just write -6. Y is equal to -6. Now you are talking. You are speaking the language of the distinctionites. So aren't you falling asleep? Just a question. Falling asleep for what, my dear? I've been requesting here again to tell you, I need you to think. I've been requesting here because, matter of fact, poetry is your form of expression. I've been wanting to hear that poetry, but I see you like, you don't want us to hear that poetry sleepy voice after dozing off, eh? All right, that's fine. 8.1.3 is the function. The question is, oh, you're not supposed to be awake. Oh, you're supposed to be asleep. Are you going somewhere tomorrow? Is the function increasing or decreasing? Don't chase out. You guys, oh, you're going somewhere. Okay. Is the function increasing or decreasing? Raylo, what is this? Look at Raylo tail, creasing. Are you funny? Raylo tail, you're unbelievable. You're unbelievable, buddy. Creasing. I mean, what is that even answering? Raylo tail. Don't be funny here. The function, guys, remember here, the a greater than 0. The b is between 0 and 1. What kind of function? What's happening here? The function is decreasing. Guys, it has nothing to do with just a alone. Remember the combo. This is a combo meal. When a is greater than 0 and b is between 0 and 1. Remember, for exponential function, your a tells you that the function is just above the asymptote. But when a is less than 0, the function is below the asymptote. A has nothing to do with increasing on its own standard, okay? So when a is greater than 0 and b is greater than 1, combo meal, above and increasing. When a is greater than 0 and b is between 0 and 1, combo meal, above and decreasing. A less than 0, b greater than 1, combo meal, below and decreasing. A less than 0 and b between 0 and 1, below and increasing. So it's a combo meal, guys. We don't look at those parameters the way that we look at them for a linear function. Yeah, we need to take into account the combination of both. Okay, so you guys need to have these things in mind somewhere up so that you don't forget them, okay? All right. 8.1.3. 8.1.3. Okay, function is increasing or decreasing? It is decreasing, not increasing, or some shortened version of the word. Decreasing. Remember, a is greater than 0, whilst at the same time b is between 0 and 1. So that is a decreasing function. Careful. Praise is laughing. I wonder why is Praise laughing. Praise, you are hilarious. Why are you laughing? 8.2. Px is equal to a times b to the power x. Passes through which points? It's 1 and 12, 2 and 48. So what about those? Find the values of a and b. So let's set up two equations. This is y, this is x. Y is 12. 12 is equal to a times b, x, which is 1. The second one, okay, so that's equation 1. Second one, 48 is equal to ab to the power 2. Okay, that is equation 2. Take equation 3, make a the subject of the formula. A is equal to 12 over b. That's equation 3. Let's sub equation 3 into 2. So in the place of a, we're going to substitute 12 over b. 48 is equal to 12 over b times b squared. Then b times b squared. Numerator, denominator, that means 12b. Divide both sides by 12, the coefficient of 48, coefficient of 12, we get 4 is equal to b. So b is equal to 4. And to find a, it's ready. A is equal to 12 over 4, which is 3. A is equal to 3. So a is equal to 3 and b is equal to 4. That's what we got. Find the values of a and b. We just found the values of a and b for 4 marks. See here, because we were given 2 points, we substituted the 1 point into the same equation and the other point in the same. Then we saw, 2 equations. We could solve them simultaneously because we have 2 unknowns. When you have 2 unknowns and 2 equations, you can do simultaneous equations. So we took equation 1, made either a or b, in this case a, the subject of the formula. Then we solved substituting into the other second equation. We got b is equal to 4 initially, and then ultimately a is equal to 3. Okay. Now they are saying we should sketch on the diagram sheet. Let's see if we can grab him. Mr. Diagram sheet. Here is him. Felicia is like saying, how did I come up with a? Need you to think. 12. What's 12? Where's the 12, my dear? What type and level is this, maths? This is like in South Africa, that would be, depending on which country you are in, standard 9 and standard 10 mathematics. If you are doing standards, it would be grade 11 and grade 12 if you are in South Africa. So it's that standard of maths. I don't know now. Yeah. What level? Thing is, Michael Scottfield doesn't seem like he's South African. That's why I'm answering the way that I'm answering. And remember, they are doing A levels and O levels in some countries as well. So that's why I'm saying that, yeah. So I need you to think. I'm not so sure if that was the grade specifically. Felicia. Felicia, you were asking Felicia. Felicia, P of X is equal to A times B to the power X. Remember Felicia? Okay, the question says the graph P of X is equal to A times B of X passes through the points 1 and 12, and 2 and 48. Find the values of A and B. So I took this point, substituted in this equation, formed equation 1. Took this point, substituted in this equation, formed equation 2. There it is. Equation 1, y is 12, x is 1. So that's why I have AB to the power 1, that's equation 1. 2 and 48, y is 48, x is 2. There it is. Then I took equation 1. Alright. Hey, we should get a tripod. I actually do have a tripod, guys. It's just that I'm so lazy to set it up. That's why you see me do this. So don't worry, next time I'll have it set up so that I can have like a elevated view. So I'm very sorry, but I'll have that happening next time, okay? Very lazy to set up. Just convenience. Lazy. As for lazy, you are very lazy. You have no idea. Yeah, lazy to set up the tripod because it's just more convenient for me to be holding my phone and just write, if that makes sense. Not lazy to do the maths, not even, but lazy to set up the tripod, definitely. Whoa, I need you to think. I feel like you'll be having us think the whole time through. Your name goes before you. Equation 1, guys. Equation 1, guys. You can either make A or B the subject. Remember, Felicia, that A and B have a relationship of multiply. So if A is multiplied by B, you can make either A or B the subject of the equation. How? All right. Then what you can do is you can divide both sides by, if you want to make A the subject, you divide both sides by B. You divide by B on the right. What you do on the right, you do on the left. So that's why the B and the B cancel. You are left with just A as the subject. And then, no, it will, Felicia, imagine my pen is like this, right? It's pointing like this. Then I take my pen, I just do this, right? Now the pen is on the left instead of the right, but it is still having that same point that was that side. It's still the same point that I'm having this side. So it's like I did the same thing here as well. If I divide both sides by B, then it cancels the B, it leaves the A alone. When A is alone, on the other side, I have 12 over B. When A is alone, on the other side, I have 12 over B. So that's how I got equation 3, right? Relationship of multiply means I can divide by the other variable. And then what I do on one side, I do on the other, okay? Then that leads me to a isolation of the variable and a fraction of 12 over b on the other side. Now that I have equation 3, I substitute that equation 3 into the equation that was not manipulated or touched. Okay. I cannot substitute equation 3 into equation, for instance, 1, because it's the same equation. Okay, so I substitute equation 3 into equation 2. So 48 is equal to a, in the place of a you substitute 12 over b, there it is, times b squared. So there's b squared. Then the b squared, this b squared is in the numerator, this b is in the denominator. So b squared divided by b gives me a b in the numerator, a single b, over, a single b. So I have 12b, and then 48. Then I divide this side by 12 to get rid of this 12. But what you do on the right, you do on the left. Okay, so 48 divided by 12 gives me 4. B is equal to 4. So I have b is equal to 4, then I take the b is equal to 4, substitute it back into the third equation. Okay, a is equal to 12 over, the b value is 4. 12 divided by 4 is 3. And that pretty much covers that. Okay. Hayi man Kitty, hey uphambene nalo Kitty, uchamisa njani lo muntu lo? Phambene. Sichamisa apha sigula apha. Block lo Kitty, block Kitty. Get rid of Kitty. Yeah, I just did. What the heck, man? What is wrong with people here? So after 22, hey, 22-1, people are crazy out here. What the hell? What the hell? What the hell? What the hell? Oh, crazy. All right, people are broke, I see. I feel you there. The poet knows it. Okay, guys, so that's how I got that one. Okay, then we are now going to go to the diagram sheet and we are going to draw and sketch our function. Okay, so let's take it one step at a time here. All right, we've got a diagram sheet. We want to sketch h of x, right? We found the x and the y-intercept for h of x, okay? And we found the horizontal asymptote. So for h, all right, I'll definitely read your poems. Yeah, people are broke, so I'll read your poems. Yeah, I'll definitely read your poem. H of x is equal to, praise, I don't, what is that? What are you talking about there? Is this Kutlwanong paper just asking, what is that? Guys, please read I Need You to Think's poems. Are those poems on your page, your TikTok page? I think I Need You to Think needs a follow there and a read of her poetry. Okay, we'll definitely check it out. I've just followed you. Okay, h of x is equal to, please guys, h of x is equal to, all right, 3 into half x minus 6. Remember, the things that we need, remember, number 1, our a value, we did say is 3, and our b is half. So that means we have an anticipated situation of something like this when we do sketch. Okay. 2, horizontal asymptote, y is equal to -6. 3, x-intercept, we did find the x and the y-intercept, remember? So our x-intercept was the -1. So we know -1 and 0. Our y-intercept is 0 and -3. Okay, so that was h of x. Now we've just found out what the equation of p of x is. Okay, because we got our a value. A is 3, b is 4, and we know it's to the power x. Okay, so now we are going to, obviously, we know a is 3, b is 4. So if a is 3 whilst b is 4, then that means a is greater than 0 and b is greater than 1. So what are we expecting? We're expecting a function that is increasing above our asymptote. What is the asymptote equation? It's y is equal to 0, because if there's no constant, then it means our horizontal asymptote is y is equal to 0. Then 3, x-intercept, y-intercept. So if I let my x be 0, p0 is equal to 3 into 4 into 0. That will be 3 times 1, which is 3. So that will be 0 and 3. That's the y-intercept. Then x-intercept, 0 is equal to 3 into 4 to the power what? To the power x. Divide both sides by 3. 0 is equal to 4 to the power x. Three times 4. Yeah, so that means there's no x-intercept. Which makes sense that there's no x-intercept, because remember our asymptote is y is equal to 0, and that's the x-axis. Okay. So let's start with h of x. Y is equal to -6. We just draw in the asymptote that's horizontal like that. Then x-intercept, -1 and 0. Here's -1 and 0. Y-intercept, 0 and -3. Here is 0 and -3. It's here somewhere in between. So then when we sketch, okay, so I think what we can do, let's just check here. 1, let's do this shift mode, mode table 3, 3. Of 3. Okay. I think I get the point. Get the point. All right. Yeah. I think if I have those intercepts, that really suffices, right? Okay, let's just go to the other function here. We have y is equal to 0. So that's basically y is equal to 0. We have y is equal to -6. Then, as far as that function is concerned, 0 and 3 is here, and then there's no x-intercept. Okay, so that means at least when x is equal to 1 for that function. Yeah, x is equal to 1. X is equal to -1. .75. x is equal to negative 2, 1,1875. So there's a sketch there. 3, -1 and 3 over 4. Okay, that's the increasing function. That is going to be my p of x. So p of x is sketched here. All right, you can see the y-intercept. That's 0 and 3. I don't have anything else here. So I've used my arbitrary points, checked when x is equal to -1. When I set up my table, when x is equal to -1, there it is. Not 0.75. Okay. Yeah, which is 3 over 4. Okay. Then, yeah, the other function, this one. X is equal to -1 here. The y is equal to -3. That's there. Then when x is equal to 1, so let's see this. -4,5. I'm -5,25. Yeah. So there's the other function. -1 x-intercept, -3 the other y-intercept, and then basically just random other points here, just so that we can see the sketch of the graph, the two graphs. Okay. So what they wanted is sketch the graph of h and p on the same set of x, clearly label all intercepts and asymptotes. So intercepts and asymptotes are all clearly labeled. It's 3. The answer is 3, Lani. Yeah. Yeah, I think we can call it a night. Definitely praise. Okay. Yeah, thank you so much, guys, for joining in. It's really appreciated. Hope you guys have a beautiful night. We will see each other again. All right. Yeah, you survived. I need you to think. You survived, eh? But yeah, you're welcome, dear. You're welcome. You guys are welcome. Have a good one. Have a great night. We'll see each other on our next segment. And also, I'll try and have my thing put up so that I don't have to move. Okay. Yeah, I'll have my thing elevated so that you guys understand. I'm sorry that I did not have that happening. I won't forget to upload quite. I'll definitely not forget. Okay, thank you, guys. Thank you. I won't. Yeah, guys, subscribe to my YouTube channel, please. Subscribe to my YouTube channel. Link is in my bio. Yeah, I'll really appreciate it. And make it rain. Comment watch, like, yeah, even if it's just random comments, guys, just go and paint my comment section for most videos red and blue. Even if you write random things like, I'm the one that slept, or clock it, like Miss I need you to think. Good night, guys. Cheers. And please go check out I Need You to Think's poems and reading. Yeah, I think we just need to practice that, like, as a daily ritual, comparable to how people usually pray before they sleep. We should just pray and read I Need You to Think's poems, don't you think? Okay, cheers, guys. TT. Okay, guys, I'm sorry, I'm gonna